Our universe is unimaginably big, but most likely not infinite. A long time ago, it was born in the Big Bang from a microscopically small object and has been expanding ever since. We cannot measure or even imagine how big it is now, but we know it should be of a finite size. However, the universe is closed, which means it has no end or border. It's like the surface of a ball, finite in size but without end. The only difference is that it is a 3D sphere, a three-dimensional surface, not a two-dimensional one we can see. Astronomical data shows us that the universe is very uniform, as we see the same stars, galaxies, and dust no matter where we look. And everything we can see consists of the same kinds of matter and emits the same kinds of radiation and light. All this inevitably tells us that the universe must be a single object with a single set of physical laws all around it. Now we even have a special branch of science that studies this unique object and its behavior, cosmology. Today, however, I won't be talking about cosmology. Today I'm talking about the biggest mystery of modern physics, why we cannot find a single set of laws that supposedly governs the entire universe. This idea sounds great. Let's write a single set of equations which explains everything in the universe. The theory of everything, or TOE for short. This TOE should describe all kinds of matter and all types of forces that physicists call interactions. Quantum physics is so ready for that. It should be not just cool, but super cool. Unfortunately, the reality is not so bright. Despite many decades of search and a few so called string revolutions in physics, we still have no TOE. Gravity is still described only by Einstein's theory of gravity, general relativity. This theory is not a quantum theory and cannot be quantized. The quantum theory of gravity is still under development. Moreover, astronomers have suddenly discovered that more than 95% of the universe consists of so-called dark matter and dark energy, things that nobody has expected and nobody knows what they are. Quantum physics cannot explain them either. Although these problems are very hard, they don't look unsolvable. What puzzles me the most is what all the laws and basic is why all the laws and basic terms in quantum physics are so exceedingly different compared to the laws and terms of classical physics. This really the biggest trouble of all. Surprisingly, most of us do not realize how huge and ugly these differences are. Indeed, we know that quantum laws are kind of special. However, we usually do not realize just how special they are. The naked truth is that today we use three different physics together. The first and oldest one is Newtonian physics, born with Newton's theory of gravity. The second physics is set by Einstein's theory of gravity, general relativity. The third one is quantum physics, presented by the Standard Model, a set of quantum theories describing elementary particles. Newton's and Einstein's theories both represent classical physics and can be combined under one roof, as Newton's theory is simply a special case of Einstein's theory. for slow speeds and low gravitational forces. However, quantum theories are based on quite different terms and cannot be merged with any classical theory under no circumstances. Well, let's see how different they are. In Newtonian physics, we have a few very basic terms. The mass, that is simply the cause of gravity, some property of matter allowing it to attract gravitationally. The force, that is simply the force that moves the bodies, and the energy, which is like the force but is not an acting, being hidden within the body. What is mass and how do force and energy come from it? The theory does not explain. Another important part of this physics is that it assumes the existence of absolute space and absolute time, a very convenient feature, allowing us to add or subtract speeds. Newtonian physics is very simple, rational, and still conveniently used in mechanics and engineering. However, it has certain limitations. When speed becomes too close to the speed of light, or when the gravitational force becomes too strong, Newtonian physics must be replaced with Einstein's general relativity. The biggest change comes with the switch from absolute space and absolute time to relative, or in a sense warped space-time. Einstein's theory still treats mass as some property of matter causing gravity and doesn't explain what it is, but it does explain the action of mass. Mass simply curves space-time, and how the space is curved at each point defines how a body will move there. The movement is not forced now, but it is free, as the body simply follows the space-time curvature. This means that there is no gravitational force, but only warped space-time described by another term, gravitational field. Energy is now representing how much space-time is curved. You can see that Einstein's physics is more advanced compared to Newtonian's physics because it can explain movement by the space-time curvature. That is nice. Now let's see what new advances were brought to physics with quantum theories. Surprisingly, these new changes in the basic terms do not seem very nice, as quantum physics describes interactions of particles. The main thing causing interactions is not mass but charge. Electric charge for electromagnetism and color charge for the strong forces in the nucleus. Charge is again some property of matter that is not explained, and that is fine. What is not fine is that other basic terms are not explained either. Again, forces are replaced by fields, but what those fields are, we simply don't know. The only thing we know for sure is that there are hundreds of various fields, and each kind of particle is a quantum of one of those fields. Like electron is a quantum of electron field, muon is a quantum of muon field, etc. What is energy? This is once again not explained. Moreover, quantum physics seems to ignore mass completely. Yes, gravity is way too weak to be noticed with elementary particles, but that is not the point. Originally, nothing in quantum physics was able to predict mass for particles. Yet physicists knew that some particles have mass, and they kinda invented the Higgs field and Higgs boson with the only purpose being to explain mass. This move seems a bit unnatural, and this is not yet the worst part. The saddest part is that quantum physics has not adopted Einstein's warped space-time concept and returned instead to the Newtonian absolute space and time. In general, this move looks like a huge step backwards. Yes, this change was necessary for practical reasons, as otherwise the theory wouldn't work at all. However, if you make such a step back, you have to explain why it was necessary. Alas, physicists remain silent. On top of that, there is a whole list of very peculiar quantum phenomena like wave-particle duality or quantum entanglement that no one can explain or even understand. These things exist only in the quantum world and cannot appear in the classical physics. Why they exist, what causes them, and why we don't see them for large objects is yet another mystery I do not get into. Now, let's get back to our main question. Where is the theory of everything, TOE? With understanding of the core differences between quantum and classical physics, this question doesn't seem so straightforward anymore. On macro scales, the universe is well described by Einstein physics, but on quantum scales, we have to use peculiar quantum physics. And nothing seems to explain why we need such different laws for the separate scales. Surprisingly, nothing in the universe seems like a border or divider. It remains smooth and uniform in any direction at any scale. And yet we have to understand the tremendous differences between the basic concepts. It seems inevitable to me that before we start writing TOE, we have to explain these differences and find a way to translate the terms of classical physics into the terms of quantum theories. Without that, no unified theory is simply possible. Wait, maybe this problem is being solved by modern theorists. Let's see how modern quantum physics propose to solve this contradiction. Well, they simply suggest sacrificing Einstein's theory and all its advances and building TOE on the terms of quantum physics only. Okay, maybe they know some tricks on how to explain gravity with quantum fields. Alas, it turns out that they continuously fail. The idea of TOE has been under development for about 50 years now, yet nothing seems to come close to success. No single theory has yet to replace the old and ugly standard model. Superstring theory explaining all types of forces. Theoretically, it is possible, and there are tons of ideas on how it can work, but practically, they have nothing to replace Einstein's equations of gravity or even those of the standard model. What about the theory of quantum gravity? The same thing. Any experiments that can prove new quantum theories? Still nothing. This seems like a complete disaster by now. There is no working theory or any unified theory. No quantum gravity to replace general relativity, and no explanation for dark matter and dark energy, something which none of the quantum theorists thus far have successfully explained. What surprises me the most is that the physicists of today ignore all these problems and continue talking about the future breakthroughs of quantum theories again and again. So, what can we do now? One obvious way is to calm down and wait. Maybe quantum physics will figure out something in the future. Every crisis comes to the end eventually. However, I'm not sure that today's theorists have a clear idea about what to do. They seem to ignore the core contradictions and bluntly fight all the difficulties with more and more complicated math, with no success. An alternative approach might be to accept that we need two different physics for our visible world and for the quantum world, but we still need to explain why and how those worlds are divided. The fact that the universe looks like a single object does not mean that it cannot combine different worlds inside it. Why and how that can be possible remains the biggest mystery of the universe, yet awaiting its answer. Thank you for watching. Please comment and subscribe if you'd like me to continue.